Okay. So first, hello to Guimarães and to Ljubljana and to the friends from all around the world. My name is Mohamad Chaaban. I'm going to be presenting to you my thesis that I developed in Ljubljana. It's about the application of the digital twin framework for BIM-based facility renovation management. So to start with the problem statement, we all know that buildings occupy a huge amount of the global energy use, around 40%. And in specifically the operation phase, which is the facility maintenance and management phase, takes up around 85% of the cost of building's life cycle. This has exposed a lot of inefficiencies in the maintenance processes and has pressured the industry to figure out a more efficient way to do stuff, which has prompted leveraging the fourth industrial revolution, using the power of BIM and IoT to create some kind of workflows that enhance these kinds of works. So what is a digital twin? It's a very fancy buzzword being used nowadays, but it can be as simple as saying that it's integrating live information that's coming from IoT sensors or coming from sensors that are monitoring the performance of assets and integrating that with static information that we have about this asset so that we can better understand what's happening. It can be as simple as integrating information coming from sensors with 2D drawings or risers, or as complicated as integrating it into BIM models and using all this to perform the management and maintenance of these monitored assets. The point of this work is more focused on the BIM side, where we want to develop a framework that helps us create a BIM to digital twin workflow that helps us leverage the semantic properties of assets in BIM for the FMM operations, gives us a BIM model rich with relevant FMM information that facilitates the work of the facility manager. Also, provides the possibility to integrate the static and dynamic information into a digital twin CDE. The project was developed in coordination with Protem, the company in Ljubljana, under the guidance of Ekaterina. The case study was an office building that's 3 floors big with 105 employees. The standards implemented were ISO 19650, COBie, Uniclass, and IFC schema. And Revit was the proprietary software used. I broke down the structure into the following steps, where we started with integrating the client FMM requirements by talking with the client, then developing a standardized naming convention, adopting a CDE, developing the static and dynamic information models, and finally compliance checking. For the client side, we met with the facility manager and we understood what they wanted the digital twin to do. So in a way, like we develop BIM uses for the model and according to that we develop an information requirement. We understood what the facility management and operation requirements, or if you can say, are required by the client, and then try to understand how we can translate that into BIM requirements. So the facility manager wanted the system to generate ISO compliant documentation, to perform facility management requirements, to have had BMS requirements and general requirements. The second step was to develop the standardized naming convention. I followed ISO standards, which mainly is supposed to provide us with unique identifiers, structure the information in a hierarchical manner, and which facilitates the retrieval of information, and it enables effective compliance checking. This is a sample of the naming convention developed, where like the models were named according to, they were broken down to the following structure of drawing owner, originator, facility name, etc. And the models were named accordingly. And similarly, the family names were all were provided with the appropriate information, such as manufacturer, model name, description, so on. The third point was to choose the appropriate common data environment. And to do that, a study was done to understand what features are required for a facility manager's common data environment, which can be summed up in the following figure, where it was required that the CDE should have proper security measures, such as role-based access control, authentication methods. It should be able to integrate the building information model and the remote data systems, which are the sensors. So it should be able to harbor both information, static and dynamic. It also should have web and mobile accessibility, facility portfolio management functions such as providing features for preventive maintenance and predictive maintenance. It should also be have provide standard based on interoperability, such as being able to export or import to Kobe and such. And most importantly, it should act as a centralized data repository for all kinds of information that are relevant to these functions. The CDE chosen was Economist Siemens. Siemens acquired Economist around a year ago, and they've been continuously working on this software for it to be one of the most prominent digital twin softwares in the common data environments in the industry. Uh, this was followed with developing the structure of the static information model. The static information model is the BIM model. And so the structure was broken down into three main parts, which is the project information, the asset information, and the room information. And each one of these was subsequently broken into more parts, such as the asset information requires designer, identity, spatial, geometrical, and manufacturer information, and similarly for the room. Now, the way this information was decided on was by taking the level of operational information required, developed from the client requirements, and doing an intersection with the Kobe standard of information that is usually required for facility management and maintenance. And like the intersection was the result of the information that needed to be placed in the BIM model. So for example, for the project information, the design information required would be the created by, created on. Identity information would be the following. And I also specified at which point of the phase the information requires to be filled, and then verified later on. So for example, all these information are required to be filled at the design phase, and then later on they have to be verified and confirmed. And this is a sample of the information in Revit. Here is a sample of the asset information. These are the type properties, and these are the instance properties of the asset. Mainly, all the information was created and populated in two ways. One way was using the Autodesk interoperability tools, which provides us with a way to assign all the classifications needed for all the assets in the model, and also create all the Kobe parameters necessary, and populate them, of course. Now, the other way was Dynamo, which was a bit more flexible and more reliable, and more customizable to what you want. The room information, this is a sample of the room information, which was mainly like the main focus of the room information is to have the temperature requirements, humidity requirements, CO2 level, lighting level, and noise level, in addition to all the area and geometrical requirements that help the facility manager monitor the performance of this room. When exporting the asset information model from the BIM model, we used the user-defined property sets to avoid the flood of information that happens when you export the model. And so what was selected was only the defined properties that were defined in the previous requirements. And so in a way, we only have the relevant information to the facility manager rather than all the information. Here's a quick demonstration of how Economist works. You first have to download the add-in of the BIM connector, which is provided by Economist, and then you go to selecting the data from the IFC schema. That's of course you first have to properly assign all the elements in your model to the correct IFC description, and then you accordingly select which assets are required to be exported, and then you export to Economist. This exports only the information to the server. The next step is to upload the geometrical model. And so the geometrical model is uploaded by simply adding the model and assigning it to the specific discipline and categorizing as what kind of information this is, which is model data. And then the information that was uploaded previously is automatically associated with the geometry that is in this model. And here we can see that the type of assets are available now in Economist: the furniture, the lighting, and the fan coil unit, and all the instances of them that are available in the model are also available here. Another feature of Economist is that it provides 3D navigation in the model, and in parallel can provide you any information required about the assets in this model. So for example, if you press on an asset while navigating, it can give you all the required component and type attributes, in addition to any live information that can be required. Speaking of the live information, an information structure was created for that also, where the sensors have three main points of information, which are the measurement, identity, and network information, which are used to properly define what the sensor is monitoring, how it's monitoring, and where it and how often it's recording this data. The dynamic information is defined in Economist as variables that receive information, and you can interface these sensors in the room. So for example, in this room, you can place the temperature sensor that is actually monitoring this room in the room itself, and then accordingly record the performance of this room. For the future works, like even though Economist is a really good software, but all the software license fees and the lack of customization and lots of workarounds were required to reach the end product. It feels like having an open source CDE that frees users from this would be way more beneficial for the industry. And as a summary, just to wrap things up, the BIM to FM workflow started with integrating client requirements, developing a standardized naming convention, adopting a CDE, which led to asset static information model and asset dynamic information model requirements, developing them, performing compliance check on them, and then having everything happening inside one big CDE. And that's it. Thank you.